Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So, topic here we will discuss today it is the galvanic cell, or its simple introduction. Basically, when we talk about the galvanic cell, first of all we will have its simple introduction or its discovery. So, the galvanic cell is basically known as the voltaic cell. So, why it is called as voltaic cell? Because scientist whose name was Volta in year 1745 to 1827 was his era. He was an Italian physicist and he known especially for the development of the first electric cell and the year was 1800. So this is the Volta. He just put about the voltaic cell and simple its development. So that was done by the voltaic, so it is also named as the voltaic cell. The other was the simple Frederick Daniel. This cell is also known as the Daniel cell. So why it is called? Because the Frederick Daniel was the first scientist who just constructed the first Daniel cell in which he take the anode and cathode cathode as a copper and the anode as a zinc. So by constructing that cell he just do the experiment over there. So that's why that's is known as the Daniel cell due to its name, which is Frederick Daniel. Now, what is the galvanic cell? What is its main working? Galvanic cell is a device that converts the chemical energy into the electrical energy. In this simple a process which is called as the spontaneous process of a chemical reaction just takes place and it is converted into a electrical energy. So the production of electrical energy just takes place in this process by the spontaneous chemical process. So this is the simple discovery and the definition of the galvanic cell or the voltaic cell. Here we have the construction of the voltaic cell. Basically, the galvanic cell consists of two half cells. This is the first half cell and this is the second half cell. Which one is the first point? It consists of simple two half cells. And these half cells are combining and making up one complete cell, and this is known as the galvanic or the voltaic cell. Now the one half cell is working as the anode and the other half cell is working as a cathode. So at one half cell, which is anode, it carries the charge negative, and the cathode, which is the second half cell, it will carry the charge positive. So this is the difference between galvanic and electrolytic cell. In galvanic, the zinc side or the anode side will carry the charge negative, and the cathode side will carry the charge positive. But the process of oxidation will take place at anode, and the reduction will take place at the cathode. Here we have the electrons flow, which can be measured with the help of the voltmeter which is attached to it. And in the center here we have the salt bridge, which is containing the potassium chloride as an inert substance in the form of gel, and this is just used to keep the solution in a balanced way. So this is a simple construction of the galvanic cell. Now how does the process will take place in the galvanic cell? We just have a look. Zinc side, it is working as a zinc anode and the copper side is working as a copper cathode. Both are filled up with the electrolyte, and here the electrolyte on the zinc side is zinc sulfate's aqueous solution and the electrolyte on the copper side is copper sulfate aqueous solution. And in the zinc solution, its zinc electrode is just dipped up, and in the copper solution, the copper electrode is just dipped up in the solid state. As we are going to just put up it into the solutions, in the center here we have the porous disc, or we can also use the salt bridge. Both can be used. When we just insert that, the chemical reaction takes place, which is called as the spontaneous process. And as a result of that spontaneous process, the electrons will be started to flow from anode to cathode. The zinc, as present in the positive 2 state, it will come into the solutions by losing the electrons. Now these electrons will move towards anode to cathode. Now the copper that is present in the solution, it will gain that electron and started to deposit over the electrode of the copper, and here the process of reduction will take place. So this is called as the oxidation half cell, and the copper side is called as the reduction half cell. Both are combining and making up one complete cell. So the electricity that is produced, it can be measured with the help of the voltmeter. When the electrons just pass out through this voltmeter, it will measure the capacity or the production of the total current in the galvanic cell. So basically the strength of this process just depends upon one thing, which is how much the rate of oxidation and how much the rate of reduction on both the sides of the cell. The one thing which is in the process of a galvanic cell, how do we be able to know that which one is working as anode and cathode? So here we just have to check the metal's activity. The metal which is more active or highly active, it will work as anode by losing the electrons. On the other hand, the metal which is having less activity, it will gain electrons and it will work as a cathode. So anode and cathode both are present in the galvanic cell, but the difference is just very simple, which is the positive and the negative charges. So this is the simple process in the galvanic cell. After this, here we have the role of the salt bridge. That what will be the role of the salt bridge? Why we just use this? Basically, it works the connection between the two half cells. On the other hand, as the half cell is containing the potassium chloride as an inert substance. Now, when in copper solution, all the copper ions will move towards the electrode. The solution will have just negative charges, and on the other hand, when many of the zinc will come in the form of positive 2 solutions, so its concentration also becomes high. When the positive on one side and negatives on the other side are going to be increased, the solution will not be able to be in the neutral form. So from the salt bridge, the solution that is potassium chloride present, where the positive ions are going to be increased, here the chloride ions will move and keep the solution neutral. And on the other side, which is the cathode side, if the sulfate ions are going to be increased, which is having negative charge, now the potassium ions will move into the solution and it will keep the solution neutral. So this is used to maintain the neutrality of both the half cells. This is why we will use the salt bridge. So this was all about today's lecture. I hope you guys understand, and if you have any queries, you may ask me about that in the comment section. And the next topic that we will discuss, it is the reactions in galvanic cell. For that time, you guys keep learning and have a good day.